Hello, everyone. I think it's time to start. So, welcome everyone, and let's talk about what's gonna be here today. So just a second, we have a coin here. I think we solved the echo problem right now. So yeah, we are fine. So I hope you guys hear me very well. Just react that you hear me good. Victor is in the same room with me, so of course he's gonna hear me very well, but I am not sure that others. Özge, do you hear me that side?
Yes, it's okay. And I think you are the host now, and I learned that you can be able to start recording.
I'm gonna make co-host as well. Okay, so let's start. Today, welcome everyone to our workshop today related to our Horizon project called Village. So what's gonna be?
May I just a minute? I cannot start recording because it has started recording. Sorry for that. Okay.
So today we are going to talk a little bit about Village project overview, what we have done, what we are doing right now. So about this process, and also we are going to get some updates today about the website that I will explain, and also the new database that we have that we are going to talk about. And later on today, we are going to talk about a little bit the existing learning models, more like skill-based. So Associate Professor Dr. Öner Uslu will be here today. So as a good thing that I need to remember to send him to link so he can join us. And after that, Professor Dr. Anita Johnson and Valdis Creed-Doles, if I pronounce correctly, we are going to talk about learning models for engineering laboratories teaching. So if you guys just mispronounced the name or the last name, please forgive me, so you can correct me. And also at the end of the workshop today, we are going to talk about global state of the art report. Also, we made like this research and focus group and see the result of it, and we're going to go from there. So the thing is, I'm going to share my screen. Wait a second. So here we are. I'm gonna make the presentation start first. Okay. I'm gonna share my screen. I think you guys seeing the screen. Okay, let's talk about a little bit our project and what we have done so far, and what's the actually a bit overview of the project. So if you joined the first time to our presentation, so it will be good that you're refreshing the knowledge, gaining the knowledge. If you're the second time, it's going to be refreshing the knowledge. So this is the actually Marie Curie project. So it's a staff exchange and supported by European Union. This project fund short-term international and intersectoral exchange of staff members involved in research and innovation activities of participating organizations. And the aim of this project is to develop sustainable collaborative project between different organizations from the academic and non-academic organizations, and based in Europe and beyond. Exchange staff benefits from the new knowledge, skills, and career development perspectives, while participating in organization increasing their research and innovation capacities. And also right now we have organizations here and also academic partners and non-academic partners here. So basically this project aims to come together and transfer our knowledge, as I'm going to say now. So our objective is international and intersectional and also interdisciplinary mobility of research and innovation staff. As maybe you can hear that secondments. Secondments is the way of researcher going to participate in organization for a month. So another objective is knowledge transfer between participating organization, collaboration between the academic and non-academic sectors. As you know that, as I said before, for example, Victor from Italy is an AI company, and they are now in Turkey. So Victor is a company side, and we are as a university, the academic side. So we are trying to understand and speaking the same terminology in a specific content. So this is the way that we are, from the academic side, we are trying to understand what non-academic side think about it, about VR laboratories, and also they're going to understand what we are thinking, because we are just more sometimes theoretical, and the non-academic side, the sector's more practical side of it. So understanding each other gonna make more effective learning environment. So that's why this is the other objective, is cooperation across the globe. So this is the project that we mentioned, Village. So which means virtual innovative learning laboratories for global engineering education. And also this project aims to re-examine the post-academic pandemic teaching, because as you know that we got through the pandemic process, and also we learn, or we just broke our fear to use technology. So the next step will be more technological and also related to educational side of it. As you see that nowadays we are talking a lot about artificial intelligence. So we are going to talk more later on in the future. So from this perspective, we try to understand needs of engineering instructor and students for laboratory practice in a multidimensional and multicultural and multidisciplinary content, and to determine roadmaps for the new instructional design models in the line with the opinion of stakeholders. Because as I'm gonna show you a little bit later on, we created a database for the instructional design models, and we asked around 20 different academicians to rate them for specifically learn VR laboratories. So if you're gonna see the grades and everything, to create and sustainable instructional models while developing a pilot virtual lab and assist learning materials to test the proposed model, means that we are gonna develop a model from the past experience of education and what came with this, and we are going to also redesign or redevelop, or definitely develop the new model for virtual labs, and also we are making a small implementation for this. Okay, so Village is a joint research and innovation project in the content of generating a sustainable learning models for a laboratory engineering education, considering the new normal. So after pandemic period, we called new normal because nothing gonna be the same after the pandemic. in the base of like using technology and educational impact of it. So we are gonna do within the partners of universities, research infrastructures and SMEs in Europe and beyond, which aims to strengthen intersectoral and also international collaboration. And this project aims to not only to design another virtual lab, but design a sustainable model for engineering laboratories education based on, as I said many times, because the main three dimensions of this project is also variables, multidimensional, multicultural, and multidisciplinary. So that's why we're going to make it that way to analyze all the data. And here are our partners. The left side, my left side, you're going to see the universities. Right side, you're going to see the companies. So we make like three different key of classification. When we say the G3, which means products and process engineering experts, like companies. When I said S7 means educational expert, some universities or that can be in that one, and also G1 is the computer science and informatics experts. So the aim of the project, these categories should be come together and understand the same language, same terminology, each other. So this is for the 8 months project. So it started 2023 and it's planned to end 2027. This is the budget. So budget more related to second months. So each partner goes to the another partner and stay there a month and exchange their knowledge and experience. So that's why this budget is used for. And also, while going to do different partners, we have also some stuff to do. So each partners know that we have before second month checklist, during the second month checklist, and the after the second month checklist we do. So these three work packages that you're seeing on the screen right now is more like active work packages, but we added that three work packages more like career development, project management, and dissemination and communication side of it, which are all they are like 48 months goes through, but other packages is like follow each other. So we are ending work package one, and we are gonna go work package 2, and also work package 2 already started. They are overlapping with some months each other. So work package 1 is analysis of instructional design models for virtual engineering laboratories teaching for the normal. So we just try to understand what's going on after the pandemic, and especially designing models for virtual engineering laboratories. And it's almost ending this work package in a couple of months. And also we started work package 2, which means we are trying to understand needs of analysis for the engineering virtual laboratories instruction design model. So we are trying to get the design models and see the gaps or see the needs to make the better instruction design model if needed for virtual engineering laboratories, the specifically virtual engineering laboratories. So after that, we are going to start with work package 3, which means the development of the learning models for the innovative virtual learning laboratories. So in this work package is basically is expected to see like a pilot virtual laboratory, but designed by the instructional models that we develop during this process. So this 3 work package gonna be total 48 months. And also other thing is in this project is a career development. That's why we have young researchers And also we are very careful about like gender equality, and also we are very careful about how this researcher, even the academic side or non-academic side, is coming together and getting this career development together actually. So this is the very important for this part of the project as well. And also the other part is project management, which is the other like many things going through and managing the project. And also, as you know, this is like a second month. The researchers are going and coming and going to different countries and trying to understand their culture as well there. So this is the project management side to make these connections and effectively and qualitatively good. And also the last work package is dissemination and communication, which we are making our progress to disseminate our outputs and also our process and try to reach many people at the same time. So as I said that this is our deliverables of Village so far. We made a global state of the art report that you can reach. And also we made open access database of instruction design models that I'm gonna show you. And these two deliverables that is open for everyone, that you can go and read, and you can, if you share your thoughts or give us some feedback about it, it will be perfect. So I'm gonna show it later on. This is our website and our social media. Please try to follow us to get the very new and the latest recent updates. So I'm gonna stop sharing the screen right now, and I'm gonna show you the platform that let me check you here. I'm going to show you. So this is the recently updated platform that you are gonna see. Thank you for this, Victor. And what you can say, or I can share it here. This is the new platform, that new design, because we had a platform and our as a team we came together and we decided to change the view of the platform. So these are the new view of the platform, and also we are going to make some changes on it, but this is a new appearance of it. So the resources that I set it here, you're going to see our newsletter. Also there's a show pop up here, so I'm going to close it now. So this is the news that we are going to share as a newsletter here. You're going to see and read, and please, as I said, that follow on our social media account, and also the database that I mentioned before. So thank you, the team of Nick and the Square Dev. They're making the great performance here, and we had 60 different models, and they got 17 to instructional design model related to virtual laboratories. And after that 17, as you see some grades here, like out of 5 or out of like some stars here as well. Make it the full screen. You see the full screen, all right? I think I'm gonna go from here because do you see the full screen? I don't see. Okay, it's coming. Now it's okay. I'm gonna go here because I'm gonna stop sharing the screen up and again. So you can see these are now the old designs that we found so far here. So you see there are like 60 different here, but we ranked 17 of them because another expert team came together and decided which is really related to virtual laboratories. The number is 17, by the way. So if you show just to click it here, you're gonna see that just only the rated scored databases. So let's see if you try to like, for example, this one, it's got a 3.88 out of 5. So it means by the way, this graded made by 20 different academician and the non-academic and academic partners, and also they went through each model and they voted and they graded for different more than 15 different categories, and the calculation ended like this. So these are the project that you can see the I'm making the same lines. For example, the can carry model, it's got like 3.64 out of 5. So yeah, this is the thing that we have done so far. Actually, this is the one of the very important output, because you can also see 60 different models, and if you go through here, you can see more details. If it's like something that the chart, if they have, you can see all the models here. And let me check this one and see, for example, Eddie, very well known. So if you go to Eddie here, you can get like more information about Eddie. So basically, we have around 60 different instructional design models here as a database, and 17 of them, which I said before, selected to be rated. So if you click here, you can select which model that you go through. For example, Assure model got a 4.11 out of 5. So this is a very good database that, as an instructional design technologist, I am. It's very good to see all the models in the same place as a database, and also ranked by integration to virtual labs. So this is the thing that I wanted to share. So these are the very new updates, as you see. Then I'm gonna just give the mic to Dr. Uslu. He's gonna talk about today the models a little bit, and also as I remember, it's like more skill-based, or however he organized his presentation. So if you have any questions about the process that is learning, let's say the village project, you can ask me now, or you can email me. So we are very happy to share with you the new recent updates. So this is my turn that I need to leave the microphone to the owner, that I'm gonna make the yeah. So he has privileges. Hello, Dr. Uslu. Dr. Uslu also curriculum and instruction from the curriculum and instruction department, and also he got his background is instructional technologist as well. So this is like the right person that we can listen what's the models, and also as a background of instructional design technologist, he can share his experience with us. Hello, Dr.
Thank you. Thank you, Fırat. Hello, everyone again. I'm Öner Uslu. I'm studying as associated professor in Department of Curriculum and Instruction. Also, my previous background has computer teaching and educational technologies. As we discussed with Fırat and other colleagues before the presentation, we decided to give some information about skill-based teaching and instruction. It is virtual laboratory, and you are discussing the models of virtual laboratories and how to teach some skills to students, to learners, with using their body. So we focused on skill-based teaching, and we want our learners to implement some abilities by using their muscles and body. So it is behavioral change. We expect behavioral change. I want to make a brief summary of the theoretical background of skill-based teaching. We are planning skill-based instruction based on some steps to make to teach and to improve students' abilities step by step. If we cannot divide all the behaviors to small parts, then it will be a big portion. So one big portion will not be enough for someone to digest. to make it digestible portions, we need to make small parts, and we need to collect all small parts. Then we can get the big idea of the behavior. Then we can reach our behavior, total behavior. So I want to share my presentation with you, and then I'm going to here just so while teaching something to learners about using their body, it is the common classification of the objectives. The Bloom's psychomotor objective classification structure is here. All learners firstly need to observe the behavior before they are going to learn. It is the perception part. Here, it is only observing and understanding the behavior's structure. We cannot start unless learners are observe the behavior, because they cannot continue what to do if they are not observe enough and understand what's happening here. Let me give some examples. If we are teaching the dancing, or we can teach to use a machine, or we can teach to drive a car. All these are psychomotor domain abilities, and we want learners use their body and accomplish some skills while using their body. So we have to start with perception, and it is have to be small portion that they can digest easily. I love the saying so much, less is more. In education, less is more is some of the effective sayings, because if we teach less, then students learn more. If we teach more, it means students will learn less. So we have to make how much amount of skills we are going to teach at one portion, at a time. So making the small portions and preparing the instructional objectives starting with the less portion, it means our students will learn more. So in the perception level, as a teachers, we have to prepare the behaviors of scenery, and we have to show how to implement the behavior in detail in the perception part. After students are going to observe the behaviors, then they are going to set their mind and their body to implement the behavior. Still, students didn't do anything at the first two steps. They didn't show any kind of behavior yet. In the second part, the set part, let's continue. It's perception, and this is the set part. Students are getting ready to show the movement, but they didn't do yet. They are setting their minds and they are setting their body. For example, if it is teaching a dance to students, to learners, then first we need to show the, let's see the whole part. We need to show the dance figures to students, and we want them observe and perceive the behaviors. Then we can ask the second step. It is time to set the body. Make your body ready to show the figure. Make your brain ready to show the figure. It is the set part. Then the third part of learning some skill is guided response. At the first time, when we learn any kind of body-based skills, all of us show the movement based on guides. It can be a written guide, it can be a video, it can be a teacher who is showing how to do the skill. At the guided response, students follow all the steps written on a guide or seeing on a screen. In the virtual laboratories, you can prepare guides with videos. It will be much more effective, of course, when we compare the written guides. But written guides and figures will be also effective to help students show the movement, show the behavior that you want them to learn. At the guided response, you can easily understand some students if it is at guided response or at the upper level. At the guided response, students are following the steps written on a guide, then they move slowly. If it is using a machine in the laboratory, they read the steps written on guide, do the first and tick it, do the second, do the third. And it is slow and hesitating movements. You easily see that learners are implementing the movement, learners are following the instrument, but the body and movement includes some hesitation. They are not do the movement fluidly. So the second one, it is mechanism part. In the mechanism part, there is no guide really around. There is no video. There is no teacher who is giving instruction to students. Do first, then this, then do the second, then do the third. There is no one around, no guide around. But students still following the guide in his or her mind. For example, the drivers who are learning how to drive first times, firstly, there's a teacher sitting next to the driver learner. Then the teacher goes away, no teacher around. She or he is driving on her own. But at the level of mechanism, she or he is still following the teacher's instructions in the mind. So you still really understand that she or he is learning the abilities recently, not have too much experience. It means he or she is still hesitating while doing the movements. If it's a new driver, newly applicable driver, then you see that she is or he is doing the movements with a big hesitation, with a big attitude. That means he or she is moved slowly. He or she is so focused on the road, so focused on the car's movement. It means the driver cannot listen to any person in the car because all the processor in the mind full of following the instructions. Not there is a real instruction, but there is still instructions in the mind. He or she is repeating the teacher's instructions. First do that, then do that, then do that, while thinking so much about how to perform the performance, then he or she cannot do anything else. You cannot give any upper level instructions to the learner at the level of mechanism. For example, if it is about teaching a dance, or if it is about teaching a machine how to use, at the mechanism level, the dancer performs the dance on her own, but you cannot give any extra instruction about the body language because he only can perform the minimum movements. For another example, if you are teaching a basketball player how to shoot to the basket, if it's at mechanism level, the player only shoots the basket, that's all. And if you observe the learner, you see that the player is hesitating and moving slowly and not smoothly the movement. So if you go put any other player in front of the learner and trying to force the shoot, then the learner player easily can confuse everything at the level of mechanism. Before putting any other new skills up to previous one, the player have to get complex overt response level. At the complex overt response level, the learner do the movement automatically. It means not the real processor here focus on all the movement applications, not the processor use all the resources here, but it make automatically, it means the backside of the brain continues to move. Then you can teach the new upper level extra movements on the previous movement. For example, in the complex over-level response, the driver drives the car smoothly without any hesitation. And when you observe outside, you see that the driver makes many of the behaviors automatically. The difference between mechanism and complex overt response is so important for teachers while teaching any kind of skills. If the students do the implications in mechanism level, it means you cannot teach any extra behavior on the previous behaviors. But when the learner come at the complex overt response level, it means now it is time to give the next behavior. Now you can teach the next step. While you are teaching how to play a basketball, if the player shoots automatically at the complex overt response, you can understand when you observe the player easily, the player shoots automatically, then you can put another player in front of the learner trying to block the shoot. Then now the player can adapt his or her shoot based on the blocker. So if any kind of laboratory, virtual or real, if you are trying to teach how to use any kind of machine, first level, your learners will do at the mechanism stage. Please don't give any extra instruction, any extra new behavior up to their recent behaviors, because they cannot focus on you. But when they reach the complex overt response level, it means they are doing it automatically. Now you can try to put new ability up to previous one. For example, driving a car goes on collecting these abilities. First, the driver have to learn how to move the car, but without any traffic, without any person around. When the learner driver do the driving at the complex overt response, it means that the learner drives the car automatically. Then you can go on the crowded traffic parts. The driver can only observe the coming persons around, coming people around, the new cars around, the complex traffic road. Then he or she can give reflection to traffic jam around if he or she got at the complex overt response level. So to help learner having the complex overt response level, we need to let them many repetitions. When a learner repeat the behavior enough time, then the learner can do it automatically. As teachers, we need to help them to make enough repetitions. After that, all the learners can get complex overt response level. Then they can adapt their behavior for the unexpected situations. Then if a child run into the car, then the driver can automatically easily stop the car. But if the driver is still learning the abilities. When a child runs in front of the car, he or she can be late to stop the car. It is so dangerous to giving complex adaptations to learner at the mechanism levels. So in the laboratories, while we are teaching any kind of machine to use, if this machine is getting complex, we have to make small portions and small steps to make our learners do it automatically, then adapt to the new situations. We can give many other examples here. For teachers, for us, while we are teaching some skill-based applications, skill-based abilities, we have to be careful about teaching them step by step. When they get automatic in one step, then we can go to the next step. Then we can go to the other step. Then we can ask the learners adapt their behaviors to unexpected situations. Unless they get automatic in any kind of skill-based behavior, they cannot adapt if situations change rapidly and unexpectedly. And the last level is origination. I'm not sure if it is fair to expect originations in schools in one semester. It is because very upper level. Because in the origination level, all the learner, the implementer, improve his or her own behavioral type. For example, there are some Olympic sports. In Olympic sport, there are some people who are originally improved their own behavior. We can give many examples. For example, in basketball, there are some kind of shoots and some kind of steps. They are called with the name of the origination. And I remember one, it's Panelka penalty. Yeah, in football, Panelka penalty. The Panelka originated how to use penalty, and it is known as his name. It is the origination level. In a project, in one semester lecture, in a few weeks, a few months course, it is so upper level to expect some original implications, original behavior from learners. And this is the very brief summary of the psychomotor domain. Here are some examples. And if you have any questions, I will have to answer them. And if you want to give any other examples or questions, we can discuss details. Yes, please. Do you have any?
I think so far there is no question, but please don't hesitate to write even chat box or email us that we can directly ask for the question to the Dr. Uslu. I think we are all set. Dr. Uslu, do you want to add something or?
No, it is the whole plan for trying to teach any kind of skill-based behavior to learners. I offer not to forget these steps and trying to continue step by step in that stairs.
Thank you so much, Dr. Uslu.
You're welcome.
With us today. So it is very important for us to see this psychomotor domain, because when you are saying the virtual lab, but it comes with VR glasses. So VR glasses also add psychomotor or behavioral effect on it. That's why the steps that you mentioned are also important. So while designing something for the virtual laboratories, it should be considered that, as you mentioned, Bloom taxonomy's domain, psychomotor domains. Thank you so much again.
You're welcome.
Being with
It was a
us.
pleasure. It was a pleasure for me.
So I'm gonna get this another screenshot today.
Yes, let me start the share.
Okay. So this is our agenda. So we're very on time actually. So today, sorry that instead of Dr. Kışla, Dr. also were with us today, and also Anita and Valdis. Please correct me if I am saying the name and last name in not the way that actually should be. So we are gonna talk about the little bit learning models for engineering laboratories teaching. So this combination will be perfect for us to understand this concept better and fit the real perspective of the learning models that we are gonna try to develop. So who's gonna be first, Anita or Valdis, how it works together?
Yes, hello everybody. Nice to see you in this meeting. And yes, today we will want to present our idea and practical experience in teaching physics laboratories. Well, this is a teacher in the school and also the teacher in the university, and it is doctoral thesis, and I think it's very nice possibility to join in this project with our idea. And today we want to present what we have at today and what is your future and how we thinking how it can be. This was your presentation about our research.
Valdis, would you please give some sound if we hear you very well? See.
So can you hear me now?
Oh, it's coming so deep, so we can not really hear.
We can hear, but very loud. Louder.
Can you hear me now?
Yes.
Yes, it's perfect.
Yeah, it's fine.
Yes, it is.
Yes, perfect. Thank you.
Okay, I just did a test and everything is okay, I hope. So I also would consider this like sharing my experience together with Anita. She's been my mentor all these years. So I will talk about mostly challenges in engineering education, specifically for like teaching physics, electronics, sensors, everything about like measuring and like acquiring practical skills. And what kind of problems, with what kind of problems we have to deal with. So.
Valdis, please check the presentation. We can see in the.
Okay, I will share again.
Yes, full screen, please. Yes.
So. And can you see right now?
Thank you. Yes, thank you. All is okay.
Okay, thank you. So in few cases we can look at teaching and learning in a classic way because we have to deal with a lot of challenges. like nowadays, learning has to be available at any time and at any place. So we have like students on site, then we have like foreign students, Erasmus students, and then we have to deal with students that can learn at a slower pace. They need to repeat everything multiple times, and many other problems with whom we deal with. But I will talk about that a little bit later. The background for this is like e-learning and virtual learning environments. And this is like a requirement actually for learning, because we need to have some kind of environment to put all our materials. And actually a lot of courses where you learn something, these courses are like only for putting in materials that you can open, you can read, but not all of them are like very effective. And I think this this term effective, it's very sensitive actually, because it actually depends on what we have to teach. But this e-learning or using virtual learning environments, it's supposed to like reduce training costs and be accessible at any time and any place if you have internet. But how about practical works? How can we do practical works that are necessary in a lot of engineering courses? Practical works are very important in teaching and learning process, especially in engineering. Without this, I don't know what kind of engineer could be in the end after learning, if you cannot do anything practically. Most like challenging skills actually are skills that require a specific, very specific this equipment. And if I can do a lot of laboratory works remotely, but few skills cannot be like learned remotely. For example, like soldering, also troubleshooting. It needs to be in a close assistance with some staff, and also also a lot of skills, also like welding, for example. And I don't know actually how we can teach these practical skills. A lot of professors use like a lot of methods for teaching. For example, simulations, like to teach all the basic concepts, and that is fine. But how we can teach these practical skills? And further, I have listed a few types of practical work that I have done. The easiest, of course, is lab works on site. You can do outside in the laboratory. And, for example, the professor can help you, and also other teaching staff. And as I said before, simulations and this virtual reality that I have tried, it is very useful to use this, as I said, when you teach some concepts, and when you do not have the equipment available. And then the simulations and also these virtual labs or tours, when you can walk through the lab and take everything and try to work with everything. They are very good and easy to use, but it's not the real life. Also, I tried remote-controlled laboratories. These you can control through Bluetooth or through internet connection, and some of them use the assistance of staff that works in the lab, and some of them are completely remotely controlled. And also, a few years ago, I also tried these experimental kits. So I prepared all the parts, and this is like very specific because I can use this method only when the parts that are necessary for the lab are small, easily like transportable or shipped through mail. And I tried this in my sensors course and also in electronics course, and I tried to do a few experiments also in basic physics course also. And it takes a lot of time to prepare everything and to get back everything also. It's a little bit strange interaction, but if you plan everything very carefully, then it's not a problem to use this type.
Sorry, Valdi, something again with your microphone. Maybe closely. Check again.
Try. I don't know,
Not good.
Usually it works very well.
No.
Now, is it better?
No. Say switch off themselves, maybe. We can hear, but not so good.
But when it stopped, now, how about now? Is it better? You know, actually,
Oh, yes.
yeah, because
Continue.
few hours a week, I also work remotely with students, and nobody ever complained before. But okay, we go further. So not every lab work consists of all these parts, but you have to take in mind that like a complete full laboratory, this protocol that students at the end like send in or present consists of these seven parts. And as I said before, not all of them are necessary in every practical work, especially if I give a task that consists only of one activity. For example, read the schematics, solder every part in its place, and all the connections are right. Then you have to like test if everything is okay, and this kind of activity does not require all these parts. And what is the most challenging? So the most simple approach is to give this lab worksheet, and after the lab is completed, then students upload the completed or filled lab protocol, and it's fine. I used to work for many years like this, but now I want to change something, and here is example how it looks. How the evaluation looks if I use this approach. So here you can see they are a little bit hidden, all these criteria where students can get points and how much points they get and their result at the end. And this kind of approach takes actually a lot of time. Especially if and not only if, but it is must to give students feedback also, and providing this feedback, it means that I have to write like separate comments about what was good, what was a little bit where students have to work on, and to try to complete their next work better. And the next, for now, I think that I can use this method, but I really want to change something to make things better, to provide faster feedback also for students. Therefore, I tried to use this, I will call it a tool, for making all my worksheets more interactive. And I tried this live worksheets, and the good thing is that I can use this and embed this also in Google Classroom and also in Moodle. And if I don't want to pay, then I can register up to 100 students. For our local university it is enough, but if I want to use more, then I need to change something. And if I don't want to pay, then I need to do something else. This live worksheets is very good for pre-lab preparation, because during laboratory works, students have to make graphs, stories.
Okay, Dylan.
Yeah, thank you. And I use this
But at the same time, we lost your voice.
You can hear me?
Very the same, the deep.
How about now? Is it better?
Very well.
Okay.
Thank you. Very interesting, actually. This does not happen usually. So I use this for pre-lab works, and students must complete this to get to actual laboratory work, because if they do not complete this, then they are not like prepared for what will happen, and then they ask a lot of questions. And I only right now I only let them do all the lab works only if they do all these pre-lab exercises, only then. And as I said, these live worksheets are very suitable for me, but it is like an outside environment, and again, students have to register, need again profiles, and in the end, to do a laboratory work, they need to get used to a lot of different environments, and I think that is not the best thing to do. So in most cases, a lot of institutions use Moodle as their learning environment. So therefore, it would be easier to do everything in one place. It's logical. And the common thing to do in Moodle, or how to use Moodle, is to use the options to ask questions, or make tests, or actually a lot of options you can use. And I have experimented, and I tried to like change and adapt a lot of these options for specific laboratory works. And I will right now tell you about what are the conclusions. So at first I tried like to use this option for asking questions. Then students have this separate section to answer the question, and after that I have to again grade it or evaluate it, but I can not do it automatically because I have to read all these answers and again give feedback. And also I tried to use to make like these different separate sections. For example, for research values, they can use this drag and drop option. For formulas, they can like choose the right one, or make the formula also. And the most complicated part is with the data, because it depends on the laboratory work like type. For example, if they take equipment and choose how they are going to do all the experiment, then I cannot like predict or calculate the answers because the input data will be different. But this method is very easy to use if they use simulation or this virtual environment also, where all the measurements are like taped or like put together, taking photos. Then the all input data is known, and I can predict all the answers that they can calculate. And this is how it looks like. In this example, the time is measured, the height, and also the mass, and they have to calculate like energy losses, friction, also energy losses due to friction. And the background is not so complicated, but still requires a lot of work, because as I said, all the answers I have to put them in. So after students do all this work, and all the answers are automatically here is one example of a simulation that I used. Here, the input data, the data actually can vary from.
Again, the sound is going down.
I'm so sorry. Actually, I don't know what happened to my computer. I'll make the test again, and now.
Actually, it's a little bit deeper.
Is it better or not?
I'm not sure. Anita, do you hear well that side? Today, Valdis, like.
Can you hear me better?
Now is good.
Yes. Yeah. Yeah.
I don't know why it happens. Okay. So here I have to also like predict or previously measure the changes from minimum to maximum value, and also put it in this this table. So I have to do all this work if I want all the tasks to be graded automatically. But it can be done. It's actually not so much of a problem, because then after that I can use or reuse all these examples, and also for providing feedback. As you all know, you all have used this environment probably. Providing feedback is not an issue. I can type in all the formulas, give examples, and show also the correct results after all the experimentation. And this is how one laboratory work looks like when I prepare all these separate sections. And it takes a lot of work, but I have prepared multiple these laboratory works for students to use. I also tried to use to embed simulations in Moodle. It actually works very well. Some developers have made the simulations, and they are very easy to use. But again, I have to do all the measurements, calculations, drawing graphs. I have to do it in a different environment, because I cannot do it here. I can make all the measurements, but nothing else. And then I tried to make these and to use these lab works in Moodle, in Google Classroom, live worksheets, and also Microsoft Excel. You can do all these parts of lab works in each of these environments, and they work very well. Some of them have a little bit different approach, but in the end, I can work with them. But the main case is that about all the registration and tutorials, also where to put these, and in the end, how easy is to use this environment. And the most concerning part for me is the grading or evaluation of all the laboratory works. Therefore, I'm trying to find the best solution for that right now. And I hope to make this environment. In the end, I have actually seen some similar environments, but they are not available for me because they are specific for some universities or different companies. But I want to make this one environment where you can do everything, where you can complete all the laboratory protocol in one place, and you can choose this laboratory type, but the environment is the same, the one place where you can put everything and do everything. That is my dream that I hope to achieve. And the method on which I'm basing and also make all the tasks is problem-based learning. I studied this, I think, 10 years ago. I have made a lot of tasks. Most of them are theoretical because they are the easiest to make. But you have to take in mind that all the basics of problem-based learning is that all the tasks have to be real-life related. Therefore, I have to look outside and try to think of the situations that students can solve. I will also tell you about some of the tasks that I have made. And in the beginning, I think this method was not used for teaching physics, but right now you can find a lot of examples. And yeah, the most challenging part is to make these experimental problem-based learning tasks, because in each step, students need to experiment or measure something so they can get to the next step. So my examples were investigating a car crash. They had to measure this coefficient of friction, take the mass in mind, take the speed in mind, and find out who is the guilty one. And for bungee jumping, I made the task not for a human, but the theoretical was for a human, but in the lab it was just this spring or rubber that we used for this weight that we dropped. That was actually very interesting. I also used this method when I prepared the task for Physics Olympiad, also safety on ice, what you need to take in mind. Also, how many rocks you have to put into boil it outside the wilderness.
I don't want to say again, but well, this the sun getting down again.
Okay, I actually don't have a lot of to say anymore. So these were my examples, and if you have any questions, then please ask. I will try again. My speaker. I don't know what's the problem today. I'm really sorry about that.
I mean, every like presentation should be has some challenges in it. So today it was your challenge.
This
But
was the most challenging I have ever had. I don't know what's the problem. I'm very
if
sorry.
it comes with technology, we all get used to be challenging everything. So this is one of this challenging. So you should feel okay. Don't worry about it.
Okay, thank
So
you.
thank you so much, Valdez and Anita. It is very important for us to see the design part of it and also the result of it, because as you know that many like learning models like design and development side, we are trying to get which learning techniques can be used in an efficient way in a like specific learning environment or the learning process. So also which kind of data that we need, or which kind of algorithm schema that you showed us, what kind of a roadmap that we should put on the laboratories and make it better and effective learning that way. So this is very like showing us and our horizon to see what's gonna be might be in our like learning models that we should consider. So thank you so much again, and also we are very on time, which is good. Here is the I'm gonna share my screen again. If you see it now, I think you see. Now it is a like last presentation about what Valdez and Anita told us, and also Dr. Uslu. If you are gonna see some combination about it, because we make like little research on it. This is desk research, so we have like 10 partners in the project, and we came together and we make the like try to understand global state of the art on this specific topic. And also we made some focus group meetings, and Professor Dr. Özge Andiş Çakır from Ege University, she's gonna present the results. And also while she's presenting, you're gonna see that what we are talking today, and also what we have experienced so far during our lectures, during our laboratory courses. So many academicians and that side of the desk research, we are gonna see that same problems there we are facing, and same gaps that we are seeing. So this is the mic that I need to give Dr. Çakır to explain a little bit detail about it.
Okay, thank you very much. Good afternoon, everyone. So first, try to make my screen share. I think it's okay. Okay. So here we go. First, I think it's when we get a bit faster. So hello, everyone. I'm going to talk about our project's globe.
We can see the notes as well. So
Oh, really?
yes.
Okay. Just a minute. I think I have
Just directly
screen,
start
so-
from the presentation that side, maybe it's better.
just a minute. So is this also the notes are shared or not?
It hasn't come up yet.
You see the notes there?
Actually, we just see the presentation, which is not started view of it.
Okay. So do you also see the notes?
No, but we see the like the presentation didn't run yet, hasn't run yet.
Okay. So I think I have to change the let me do it the other way.
Today's
I'm using
challenge,
two
so-
computers, so I will just better, I think at the moment.
Uh-huh.
So let me start with this. Just a minute.
Yes, now it works.
Yeah, I think it works. So yeah, again, so I will talk about the Village Project Global State of the Art report. The full report is published and it's in our webpage, so you can download and get the details. However, I would like to discuss about what we have done until now. We have made a desk research first, and then we made some focus group meetings. And so this deliverable contains all of the information that are in two main parts. So I will try to discuss it in two different sections. First, I will talk about the desk research, and then I will talk about the focus group analysis. So the desk research is a very comprehensive study which contains 30 years of period starting from 1993 to 2023. And we have given some keywords while searching the literature, like virtual learning, laboratories, engineering, and education. And the total team has reached 201 publications in this 30 years of period. So when we were analyzing this literature, this huge literature, we have divided into some parts, starting from infrastructures, access to instructional design processes, instructor and student interactions, learning environment, learning materials, content development and lecture processing, also assessment and evaluation processes, and finally, we have read some problems, solutions, and suggestions from them. Starting with these sections one by one, what we gained from the literature is the literature review provided us a very general overview of the infrastructure access. So from the infrastructure access point of view, we had seen that there is a deeper examination in the recent publications, because the infrastructure about virtual laboratories has been gaining importance, and after the post, as we call it, post-pandemic, there are very important changes in the engineering education infrastructure, which is emphasized in the literature. So, regarding the instructional design processes, we have learned from the literature that the use of technology in engineering education has been changed. It supported the learning-centered processes mainly. So in the recent years, student-centered studies have gained more information, more importance, and more attention. So what are these learning-centered processes that are also gaining importance in recent years are gamifications, simulations, virtual laboratories, and 3D environments. And also, we can also add AI supported environments that provides us a new way of thinking about instructional design. For the instructor and student interaction in engineering education, of course, it depends on various technological developments recently. Of course, the importance of teacher and student interaction has been further emphasized in the recent studies. And we have also seen that the learning experiences has been changed. And the importance of teacher and student interaction has gained more importance. And so about the learning environments, of course, the technological developments are constantly changing in parallel with the technological developments. So in the recent publication, we see that the effect of distance learning become visible, noticeable, of course, during and after the pandemic period. And effective use of virtual laboratories, especially if they are enhanced with discovery and problem-solving focus, and the use of virtual learning environments, virtual reality environments, have been increased during these years. About the learning materials, of course, the changes in engineering education, it is also evolving in parallel with the changes in the learning environments. In recent years, especially digital learning materials have been increasingly used. As the technologies such as virtual and augmented reality, robotics, simulations, and artificial intelligence have gained more importance in engineering education. So, of course, the content development and lectural processes are changed in engineering education. It is influenced also by growth of evolving engineering fields and new engineering areas. So it is not due to the technology change only, but the changes in engineering as it develops technology itself. So changing in these teaching strategies have affected the content development and course processes, and all these processes have been enriched with learning environments and digital materials. And changes in teacher roles have affected the teaching processes, and also the learning processes have changed parallel to the teacher's competencies. And also, we have gained a lot of information about assessment and evaluation processes, because assessment processes play a critical role in determining the success of both students and the success of the education, engineering education itself. And in the recent years, various assessment methods and tools have been developed. And virtual laboratories have become very important tool for not only teaching, but also assessing the student performance. So coming to the problems, solutions, and suggestions, we have seen that mostly the teachers and the learners experience some challenges with internet connectivity problems, some technical issues, and problems about accessibility. However, most of the literature suggests us that infrastructure development is necessary. There should be also some training and support training courses, and for teachers to have more competencies in the VR and laboratories, and also some support programs are suggested. About the conclusions of the desk research, we can say that virtual labs have become essential tools for engineering education. With advancement in the technology, they are continuously being improved to enrich learning experiences and also enhance student access. So the our research sheds a light on the role of the virtual laboratories in engineering education, and it serves a guide for future development. And so by addressing all of these challenges and capitalizing on opportunities, we can say we can continue to enhance the efficiency and the relevance of virtual laboratories in preparing the students for the challenges of tomorrow. And of course, our research didn't end with only desk research. We have made a focus group meeting analysis in all of the countries in our project. First, let me show the different countries. We have reached engineering instructors from 7 countries, and in total of 40 participants joined our research from Ireland, Spain, Slovenia, Greece, Latvia, Turkey, and Azerbaijan. And we also discussed with them the roles of instructors and students, the instructional design and teaching strategies in the new normal. We gained some insight about their interaction with students. We asked them about new learning environments, new digital course materials, and we asked them about if they are wishing for an applied training, what could it be, and how the assessment and evaluation should be in this new era, and what their suggestions are. So we asked them first about the roles of instructors and students, and the first question was, what should be the role of instructors when integrating a VR lab in the teaching subjects? Indeed, we asked them in 3 phases, in the pre-course design, in-course design, and post-course design. Sometimes it is not very understandable what we mean by these three phases of course design. Let me first explain and then talk about the instructors' main feedbacks about the roles of instructors and students. So this instructor role is more than the design of the environment, more than the design of the environment, I mean the pre-course design. They need to first set the learning objectives and guide and also support learners during the learning process, and also evaluate the students' assessment and achievements. This is called as post-course design. And the instructor, once designs the course and the learning environment, the instructor will be in the background, in the mentor role during the in-course design. So mainly in the focus group meetings, the instructors believe that they have roles in all stages of the course design, but mainly in the pre-course and post-course phases. So in course, they think that while they design the course, the laboratory work or the laboratory experience should be done mainly by the student, and the instructor should be in the background as a role of a mentor, in the role of a mentor. About the roles of instructors and students, we ask them questions about what are your students' learning needs by using VR Lab. I mean, are they need to learn the engineering theories by VR labs, or are they more likely to learn engineering applications, or they would like to be really in the laboratories and do the research, do the activities in engineering laboratories? And so we also asked them, for what reasons do you think that your students might need such environments, or for what reasons do you think that you might need such environments for teaching? So the results shows us that the roles of instructors and students are quite important, because students' learning needs reveal that they have to first understand the theory beneath the engineering applications, and visualize them, and understand the real-world engineering applications in laboratories and experience by trial and error. And normally in engineering laboratories, sometimes there are risks while they are doing in-hand experimentation. So this controlled learning environment is more likely to be risk-free from the viewpoint of students and teachers. So that if we use kind of experiments and simulations by using VR, students can also perform some laboratory experiments that are too expensive or too dangerous to conduct in a real world laboratory. They can even reach very high-tech laboratory equipment without an infrastructure or an expensive development of a testing program. So VR Lab can also improve the students' critical thinking and problem-solving skills, which is very important and emphasized by most of the teachers in the focus group. And because experiential learning and accessing to real-world engineering scenarios can be possible by using VR Labs. And also the interaction is emphasized by the teachers, because while visualizing these tests and experiments in VR Labs, we can also provide some interactions for learning complex engineering systems in a safer and controlled environment. So these were all about the instructional design, but then we asked them, do you employ an explicit instructional design in your course? Of course, not all the teachers in the engineering, all the engineering instructors that we have talked has high level of knowledge about the course design. But of course, we have simplified the questions by asking them, how do you think that the new normal will require changing in course design? How do you think that the new normal will require changes in your teaching strategies? and what additional changes are you forecasting for your future engineering course? And instructors think that approach to instructional design varies from explicit models to more flexible and to more intuitive methods. So the new normal enables them to adapt to teaching methods, to change their teaching methods to distance learning, hybrid learning, and blended learning, and bringing new teaching experiences for them. So they need to develop new teaching strategies that incorporate the technology-driven learning, and also to increase student motivation, because it is really hard, as I also an engineering teacher, have experienced a lot of challenges to motivate students while learning in distant ways. And what type of instructional design support do you think will be useful for successful implementation of VR labs? We asked them, what kind of support do you need to implement them? In terms of pedagogical support, in terms of technical support, and we also asked them, what kind of strategies do you need for implementation of VR labs? So their replies were really as expected, because they need both pedagogical and technical support. For example, such as the development of VR supported courses that are aligned with the instructional goals, training on VR technologies and VR content development, and also troubleshooting the problems. So the instructors also think that collaboration with colleges and sharing best practices may also help them reach their goals. And those teaching technologies for successful integration of the VR lab in engineering laboratories may need interactive feedback for learners, as I stated before, with a student-centered approach, for example, including project-based learning and sharing some real-life experiences from real-world applications and so on. And then we asked them if what kind of an instructor-student interaction is necessary in this lab. We asked them what kind of, how can you ensure instructor-student interaction? We also asked them, thinking about a VR lab to support your courses, how can you ensure the instructor-student interaction? Those focus group participants all believe that in traditional engineering laboratories, the students need guidance, demonstration, experimentation, support, evaluation, and assessment stages. Of course, VR labs will need those stages, but then they say that some of these phases can be ensured, the interaction can be ensured digitally, and the students can meet with the instructors during office hours, which can also possibly be digital, and active participation in lab facilitates activities and facilitating in-class communication. So they will have more time for interaction in conclusion, if some of the test and experimentation phases are carried to VR labs. So this is interesting, because I think the students and the teachers would like to interact more with their students and need more time than mainly instructing them, guiding them, and implementing the tests in the laboratory. So they also think that the interaction with students can be optimized by using some technological channels, for example, via the VR software itself. They can give directions through the software, they can ask and reply questions from the system. So basically, they are hoping for a VR lab which is interactive. Not one-sided, but two-sided, so that the expectation from the teachers from this viewpoint is quite interesting to point out. And Then we asked them what kind of new learning environments do you think will be in the future, in the new normal? What do you think? How do you think that VR lab can be as a learning environment? And their expectations are quite interesting because they think that the new learning environments should be engaging, it should be technology adapted, flexible, and attractive for the learners. But VR labs can be complementary to traditional laboratories, but they cannot fully replace them. That is what they say. They may improve the understanding of theory and practical courses, but in some cases, we might need the traditional laboratories for hands-on facilities. And of course, VR labs are quite promising for them for adapting the new learning environments that offer flexible, economical, and safe learning environments. And among the advantages of VR lab, accessibility, safety, cost effectiveness, and ability to simulate some complex scenarios that are not easy to reach equipment are emphasized by the focus group participants. About the new learning environments, what do you think the VR labs should look like? Can you give us a solid example thinking about a specific engineering subject to be adapted in a VR lab? So I'm not going to give all the solid examples because our colleague has already presented some solid examples because it may change from an instructor to other instructor. But the general viewpoint is that VR lab should simulate the real world experiences as much as possible. It should also consider the safety procedures and show the learning, the possibilities in case of, for example, failed experience. If there is a failed experience, what happens? The students should experience it and understand the reasons correctly. And VR labs should be open to collaborative learning and also facilitate, as I said before, this instructor-student and student-student communication. It should align with the engineering theories and also include some other interactive elements. Among the solid examples of engineering subjects that can be adapted to VR labs are, for example, they mentioned about heat transfer with heat exchangers, tuning coils for a changing inductance, and simulations, for example, for electronic spaces. And of course, we asked them, what kind of course materials, what kind of new or digital course materials they need for adaptation in the new normal, and what kind of new course materials should be designed for VR labs. And they think that the digital course materials have more flexibility. They can adapt it to a changing curricula, they can easily update it, and they can adapt it to diverse learning needs. And also they emphasize that the students will be able to learn in their own pace so that it is easy for them to implement for different learning needs. Also, the new digital course materials and their use in VR labs facilitates to reach these learning materials anywhere, anytime, regardless of the students' limitations. And of course, this is very important to mention. There should be also some limitations of students to reach real laboratory equipment. And those limitations are also minimized by new digital course materials. They can also perform high-risk experiments. Sometimes VR would be the only solution for doing such high-risk experimentations. And they think that while designing the VR lab, the students will have adequate time to engage with the learning materials. So time limitations and distance limitations are all minimized while they use these new digital course materials. And we also asked them, in which engineering courses do you think it is efficient to integrate VR, and how long do you think that VR labs should take in a semester-long course? Of course, I'm sorry. Of course, they said that a wide range of engineering disciplines can provide some experimentations in mechanical engineering, electrical, civil and chemical engineering, and computer science and software engineering. And we can use VR technologies to supplement these experimental learning. About the second question, how long do you think that VR labs should take in a semester-long course? There were very different answers, so that we cannot comply it in one sentence, but there were different expectations, but we think that the time dependency is really minimized, so that the teachers can think that a semester-long period, long course should be in different time periods. And finally, we asked them their assessment and evaluation techniques. If they implement a VR lab in their courses, how do they think that assessment and evaluation should look like in a VR lab course? So there were very nice, very good example suggestions for them. We asked them how often should the learning be evaluated, how often should an assessment be given. So we asked them how they deliver those assessment techniques. So in terms of evaluation, the instructors suggested a combination of automatic evaluation from the VR systems and a traditional evaluation methods, such as quizzes and exams. So teachers never would like to get rid of the quizzes and exams part, because it is important to understand the teachers, the students' success, but including those such of student surveys, giving some projects for evaluation, using gamification as a part of assessment and evaluation are very interesting suggestions from the focus group participants, really. And they also think that they can get real-time feedback from the learners. They can make some periodic evaluations as well. And so while assessment and evaluation process in VR labs ensures that student performance is comprehensively evaluated, and the participation of the students should be also it is also important in the design and evaluation parts. So according to these all focus group meetings, we concluded that instructional design models for adapting VR applications to engineering courses, we didn't use some design models were not used during the pandemic period. Some of them said that they easily used some new models, but there were some different opinions about the use of instructional models from teacher to teacher. So there was no clear consensus about the effectiveness of these models. So even we come to the conclusion, we think that we have to give them, we have to provide them, we have to suggest them the learning models which is appropriate for designing VR lab courses. Thinking about student-centered approach, project-based learning, getting the practical experiences from real world, we can suggest them a technology-supported and a model for designing their technology-supported learning and increasing student motivation. They also agree that this was one unconsensus point of view, but in consensus, they said that they help teachers, the VR labs help teachers to transform the theoretical knowledge into practice, and doing this by reducing the risks, and also doing this in an economical way, because the real labs sometimes has a huge economical problem for the administrative of the research institutes or universities. And they also offer to learn remotely at their own pace without time constraints, as I said before, and also they needed pedagogical, and the teachers needed pedagogical and technical support. The pedagogical support for developing courses, which is compatible with VR technology, and also trainings on VR technology and VR content development These were the most important conclusions derived from this focus group meeting. What about instructors' motivation? They would like to, they are motivated to integrate the VR labs in their courses. They are aware of the challenges. They would like to choose the correct methodology, and they would like to have the properly structured instructional design. They know the limitations, but they would like to adapt to VR technology and engage students from that way. So we can say that for benefiting from VR labs, we have understood most of the challenges and gaps with the experience we gained from the engineering instructors, so that we are hopefully going to help them design courses for more effective laboratory experiences. So on behalf of my team, I would like to thank you very much for joining us. And if you have any questions, I'm ready to read. So I think there is a problem with my camera, so you could only see my hair, but now I'm here. Sorry for that. I didn't recognize it while I was looking at the presentation.
Thank you, Özge. It was a great presentation. So also it's very summarized what we have done so far, and it's also showed us what's gonna be next. So from this data and these results that Özge presented, so we started to create like our next steps. So thank you so much again. If you have any questions, please don't hesitate to ask. If you don't have any questions, please, there's a feedback for evaluation form in the chat box. Would you please make it more, fill it out, please?
Is that a question or?
I'm
I
seeing
heard a
the
voice.
question. No, there's no question. But if you have any question, just grab the mic and ask, please. It's fine. So we are getting end of our workshop. So last thing that I need to thank you to all my team, all the team that we have 10 partners here. So we are gonna take family pictures. So that's why I'm gonna ask you guys to open the cam. But the thing is, we are working more than a year with 10 different partners. And so many people ask that it's difficult or not. Of course it's difficult, but it doesn't mean that every project has difficulties. But with this 10 partner, I mean, I'm not saying Ege plus 9 partners. So we make very good collaboration. We just understand each other better day by day, because we are coming different perspective and also different backgrounds. And I would like to thank you all the partners first, because they made this project getting best. And also the presentations before today that Anita and I'm just trying to see his name, but he's just he's not here now, I guess.
Valdis.
Öneruslu, and Özge. And thank you for making the workshop so valuable today. And we also get many new things, and also got our backpacks, new knowledge. So we are gonna carry with us rest of our lives. And also I would like to thank our team behind the camera. We have a team, Ege team. So they are working making the connection better, trying to presentation more readable and more polished. So thank you, our Ege team as well. I'm just talking because at the same time I'm trying to get you guys fill out the evaluation forms. So please make the evaluation form filled out, because it's important for us to make the next workshop better.